Circles and inscribed angles. Now, we've taken a look at circles, we've taken a look at angles. What happens when we combine the two together? So, there are two possible things that we've got to deal with. One of them was what happens if the vertex of the angle is on the center. Taken a look at that already. What happens if the vertex is going to be on the outside of the circle or on the edge of the circle? That is when we get an inscribed circle. Okay. Now, the arc formed by the inscribed circle or the inscribed angle is called the intercepted arc of that angle. So there's two things that we have going with this right now. They're related to each other, obviously. Whatever the angle is out here, it's doubled over here. If I take a look at this one, I have a diameter going through here. That's 90 degrees. Well, this is 180 degrees if we think about this being a semicircle. So what I want you to do is I'm going to give you a couple minutes. Make sure that you put this into your little. Alrighty, so let's give this a shot and see what we can come up with. So if I want to name an inscribed angle, well, if I'm looking at this, I could see that J, K to L is an inscribed angle. Okay. Terminates on the circle, vertex is on the circle. Name the arc intercepted. Well, we have, that would be arc, that's going this way. So that would be arc J, L, put that over that. Now it says if JML is 52 degrees, what's the angle measured here? Now we had seen before that if this was 52 degrees off the center, this would be 52 degrees as well. Is that correct? Yes? No? Now, if this is 52 degrees here, what should this one be over here? Well, it should be half of it, which is 26 degrees. As long as you keep that in your mind, vertex is going to be half of this. So now, I want to prove this idea of theorem 47.2. Well, this one is easier than it looks. How many degrees is that? 180 degrees. And the rule that we have from 47.1 tells us that if this is 80, this has to be half of it, correct? So this has to be 90 degrees. By, if you want, we can write it down as theorem 47-1. That's it. That's all I need. It's a diameter, cuts it in half, 180 degrees. That cuts it down 90. By the way, this also implies that regardless of where D is on here, I could have it sitting over here, I could have it sitting over here, it will always be 90 degrees. So, I'm going to give you a moment here, and I want you to see if you can figure out how you would prove this. Okay, so here we go. Do these two have to be congruent? Well, let's take a look at it from this perspective. If I have angle ADB, by the way, do I know what angle it is? Do I know what the angle measure there for ADB is? No. So what could I put down to represent that I don't know it, but there is an angle measure? An X, yes. I can put an X down here. So that means that this arc up here would have to be what? Okay, so this has to be 2x up over here. But now I'm looking at this angle here from B to C to A. It has the same arc, and this arc is 2x, correct? So if that arc is 2x, what must this be here? X. It's got to be half of it. There you go. That's all it took. So if I want to find the measures of angle 1, 2, and 3, well, first offhand, I know that. How many degrees are there in a triangle? 180 degrees in a triangle. Yeah, triangle, not circle. It's okay. So, first offhand, 180 degrees here. This here is 76 degrees. So what should this angle measure here be? Half of that, which would be 38. So if I subtract off 38 degrees, I would be left with, was it 142? Now, right? Okay. So I need another angle measure. I don't know what 1 is. I could know what 2 is. Ooh, I know what 2 is, now that I look at it. Isn't 2 opening up to this? If I have a line going from one side of a circle to the other side of the circle through its center, this is how many degrees? 180. So if that's 180 degrees, this down here must be what? 90. So if I take off 90 degrees here, I am left with the grand total of what? 52. So that means that this measure over here must be 52 degrees. By the way, if that's 52 degrees, what would this be over here? 104 goes the other way, 104. If I take 76 and 104, do I get 180? The big idea is to understand the relationships between these things. Okay? As long as you got that idea that you know the angle, the arc is double. If you know the arc, the angle is half. So, I'm going to give you a moment here, and I want you to do this one. Now, what I'm going to say is going to probably seem a little mean, but this shouldn't have taken you more than a few moments to realize what was going on here. Okay? Is it cut in half? Okay. So if I know that this is cut in half here, that's 180. This here has to be 90. And once I know that that's 90 and those two are the same, they got to be 45 each, right? Is it that quick? Can it be that quick? Okay. So, and give you a few moments, please put this one down. Okay. After we've taken a look at this, it should hopefully become more obvious as we go through this. Angle 1 is going to this arc. Angle 2 is going to the exact same arc. And because we know that that rule is going to be half of whatever the arc measure is, we've got it. So if I'm looking at this, I want to find the measures of angle FGH. So I'm looking at this angle measure right here. What should it be? Should be 18, right? Should be half of whatever 36 is. Okay. If this here is going to be 48 degrees and it's moving from here to here, what should this be? 96. Because it should be double that. Okay. What about this one? How do these angles relate to each other? Well, they're opening up to the exact same arc, so that means that 2c plus 9 is going to be equal to 3c. Now, I'm going to subtract 2c here, subtract 2c here, and I end up with 9 is equal to c. So if 9 is equal to c, I put that in up over here. 2 times 9 plus 9, and I end up with what? 27 degrees. But again, it's just about knowing which ones go where. So, I'm going to give you a moment or two here, and I want you to go and figure out what this one is. So, who believes that they have the appropriate value for x? Yes, Hannah. 17. Okay. Let's check, just double check. Now, they're opening up to the same arc, so that means that 2x plus 10 should be equal to 3x minus 7. Well, I'm going to subtract 2x here, subtract 2x here, add 7 here, add 7 here, and 17 is equal to x. Absolutely correct. Good, 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 good. So I'm going to give you a few moments here and put this one into your notebook. So basically it points out that opposites here have to be 180 degrees. If you think about this for a second, if I'm looking at angle P, okay, it opens up to this. Okay. If I am looking at angle N, it opens up to this. Now that's all the way around the circle, right? So this takes part of it, this takes the other part of it, and all the way around the circle is 360 degrees. What's half of it? 180. So that would make sense following the information that we have, okay? That the arc will always be double what the angle measure is, and the angle measure will always be double, or will always be twice, or half of, excuse me, the arc. What were you going to say? Okay. Same way. If I go and take M here, M opens up from here all the way around to here, correct? O opens up from here all the way over to here. Okay, when I'm taking a look at the angles, so if I'm looking at this angle right here from O, O opens up from here to here, correct? So that means that this arc is what angle O opens up for. Does that make sense to you? Okay. Now if I go and take angle M, which goes over to here. Now notice how these endpoints end up at the same place, correct? This has the rest of the circle. Okay? So because this one opens up with this portion of the circle, this gets the remainder of it. The circle is 360 degrees. The rule is whatever the arc measure is divided by 2. 360 divided by 2 is 180. Okay. Also, here's another thing. How many degrees are in a quadrilateral on the inside? 360 degrees, correct? So if angle P here and angle N would equal 180 degrees, that means that these two here must also add up to 180 degrees, right? Because there's only 360 degrees in a quadrilateral. Does that kind of help out? Yes, no, maybe so. So, I'm going to give you a moment or two here, and I want you to think about this as I'm doing this. I need to find the measure of angle U. Angle U is right here. Now, if I use the rule that I have, that means that 4z plus 3z plus 5 should be equal to what? 180 degrees. So that means I get 7z plus 5 is equal to 180, subtract 5, subtract 5. 7z is going to be equal to 175. And last I checked, there were 7 quarters in $1.75, right? 7 quarters in $1.75. See, whenever I see numbers like 75s and 25s and 50s, I always go back to money, especially if I got to divide it out into different things. So z is equal to 25. So that means that 3z plus 5, let's see, 3z would be 75 plus 5, 5. So that means that this is going to be 80 degrees. Well, what's 4 times 25? 100, right? 180 is 180. So we give you a few moments, and I want you to do this. All right. So what is the measure of A, partner? Well, you were talking. I figured you probably had the answer. Yes, I know. You're communicating using verbalizations, therefore talking. So I figured you had the answer. What do you got? Okay. Well, let's see. Did you show all your work? Okay. So basically what I need to do here is I need to figure out what in the world X is, correct? So if I'm looking at this, angle A is right here. The other angle that I should take into account then would be angle C down here, correct? So that would be X plus 16 plus X minus 18 is equal to 180. So 2x plus 2 is going to be equal to 180. Subtract 2, subtract 2. 2x is going to be equal to 178. Divide by 2, divide by 2. X is equal to what? What would x have to be equal to? Yes, sir. Yes, it would be. That was my mistake. I was getting ahead of myself. So, as it was pointed out, this should have been minus 2. That'd be plus, that'd be plus, that'd be 182, which is why my brain was not working, because I had seen this before, and I was just like, oh, what did I do wrong? So this turns out to be what? 91. So now I've got 91 plus 16. So 91 and 16 gives me a grand total of 107. How did I get that first two? Because I have an x here and I have another x here. That's where the 2x comes from. Yep. Yep. But again, see, this is why I keep telling you guys to write it out, show the work, so that you can see these relationships and put them together and use them. So let's try this. Circular radar screen in an air traffic control tower shows an aircraft pass. The control tower is labeled as R. One aircraft must fly from point T to control tower R, and then on to the destination at point P. So what I want to do here is I want to figure out what all of these possibilities are, because the one I am looking at is right here. That's the angle I want to get to. So If I take a look at this, I have an angle of 32 degrees that goes from here to here. So that gives me, and by the way, would this line continue all the way through? Yes, no? Yep. So how many degrees is this going to be over here? Okay, 64 degrees. Alrighty. So I see that this here is 82 degrees up here. So what should this, okay, now the problem is I can't do that to this angle, can I? Is that the center? No, it doesn't look like the center, so I can't use this angle. But I take a look at this and I see that I have this running over to here. So that means this angle in here would be how many degrees? 41. Ooh, hold on a sec. I see a line coming up through from here to there. So does that mean that this one is 41 degrees? Okay. So since we're looking for this angle measure right here, if I knew what this was, I'd be golden, because then I could go and say, hey, vertical angle theorem. Do I have enough information to do that yet? Yes, I do. I got a triangle down here. I know that it's 180 degrees for this triangle in here. I take off 32 and I'm left with 148, right? I take off another 41 and I'm left with, whoops, sorry. And that would leave me with what, 107? So that means that this angle measure here would have to be 107 degrees. By vertical angles theorem, this one down here also is going to be 107 degrees. More often than not, drawing out the picture, as I've told you before, provides you with the information that you need as you're doing it. So, let me give you a few moments here, and I want you to go through and do this stuff. So, let's see. Who's got the right answer here? Or correction, I should say. Who has an answer? Logan, what you got? 106. Any others, by the way? I'm not saying that it's right or wrong. I'm just wondering if there was anything else out there. Now it says a radar screen at the air traffic control tower shows flight paths. Again, we've got pretty much the same thing. They want us to find the measure of angle M, L, P. Pretty much the same thing again. So, as I go through and do this, I see that I got a 94 over here, so that creates that angle over here as what? What's half of 94? 47. So that's got to be 47 degrees there. Likewise, that would also be 47 degrees up over here, which is the same thing. Really wouldn't matter all that much, would it? So, do I have enough information to answer it now? Most definitely. I've got my 180 degrees in a triangle, subtract off the 47, and I am going to be left with 133. Subtract off the 27, and I am going to be left with what? 106. There you go. Assignments due at the end of class tomorrow.